Hello, everyone. I am Junaid Abdul Jabbar, working as the database manager for Mapping Archaeological Heritage in South Asia project. So the project is funded by Arcadia and it's based in the University of Cambridge. Our PI is Professor Cameron Petrie. In this session, I will be talking briefly about arches in general and then how we are using it at MAHSA project. So a bit of a background for the project. So MAHSA project is focused on documenting the endangered archaeology and cultural heritage of Indus River Basin, which covers most parts of Pakistan and Northwest India. It's a collaborative research output to produce a research repository using the Arches online database platform. And we have a built-in concurrent training program to ensure long-term sustainability of the project outputs. In terms of data sources that we are using to document all these archaeological sites, we are using the legacy data publications, then historical maps that predate large urban and agricultural expansions, mainly from the Survey of India. So far we have georeferenced historical maps covering over 900,000 square kilometers. These maps are fed to a machine learning algorithm that identifies different types of mount features from it, which are further studied using remote sensing, including images from Corona, Hexagon, and Google imagery, and then also through ground truthing in field surveys. So all the data that is getting collated is going to end up in an instance of Arches database, where Arches is basically an open source web-based geospatial information system for cultural heritage data management. It was initially developed by the Getty Conservation Institute and World Monuments Fund. It offers quite a lot of capabilities around data management, data discovery, visualization, and project management. On the image at the bottom, you can see the interface of search page for Arches. On the left-hand side, we have a listing of all the records, or we call resources in Arches. And then there is a map view. You can do like non-spatial search, spatial search from the map view, and also temporal view based on the time attributes. Users can change the base map according to the requirement, export data if they have the right privileges. In terms of data structure, Arches uses SciDoc CRM ontologies and works by mapping the data attributes onto SciDoc classes. That it uses a special graph structure, which is known as a resource model. And resource models are comprised of branches and nodes. So for example, if we have a resource model for the heritage sites, it can have a branch of name, which can have two nodes, one to record the name itself, and another node can be name type, like whether it's the primary name of the site or the alternate name of the site, and so on. You can include more branches and nodes to have all the attributes you need in your resource models. Among the data types that Arches supports, there's a long list. It includes like it supports integer, string, EDTF, extended data type format. And there is also a special data type known as concepts, which allows you to have controlled vocabularies in Arches. So any attribute where you want the users to only select predefined terms, you can assign it a concept data type, and then you can populate your Arches instance with the right terms. Like here you can see field activities have control terms, condition assessment, survey, emergency impact assessment, and so on. This allows standardized data within the database and helps with homogeneous search results and keeps the database clean. Arches also allows us to relate resources across the database with defined relationships. So in the example at the bottom right, there is at the center you see a Punjab number 44E10, which is a historic map resource, and it is related to three other resources, which like it's related to Cambridge University Library with a right held by relationship. Then it's related to Jack Tomini by a carried out by relationship with because he done the georeferencing for it, and it was published under the direction of S.G. Burrard. So you can keep on linking the resources to make a knowledge graph in the database. These resource models, so each project can make their own custom resource models as per the requirement, and the resource models can be simple or complex in structure. Because this is a tree-like structure, so there is a possibility that you can keep on nesting branches within one another. For example, one site can have multiple conditions, and then each condition assessment can have multiple disturbance or threats associated with it. Depending on how much complex your data structure or resource model is, you see some challenges importing data into Arches because you have to keep track of the hierarchy of parent and child objects within your data. So once you have the resource model and you have the data, there are different ways Arches allows you to import it into the database. So it supports CSV import, shapefile import. The first two methods are more useful when you have a simple resource model, not a very nested one. Because of the limitations of CSV and shapefile, they are relatively flat data structure as compared to like a relational database. But the last two, JSON import and SQL import, they can be used for a simple one or a nested resource model as well. In the previous version of Arches, you have to use only the command line to import data into the database. But now in version 7.5, which is the recent one, the latest one, we have a GUI known as Bulk Data Manager, from where you can get a Arches compatible template for your resource model, populate it with data, and then push it into the database instance. For our MAHSA data import pipeline, we are using SQL import. This is because how our working is set up. When we were dealing with our data set and the legacy data, so we noticed that there is a lot of issues of data duplication, or one site being listed by like 5 or more resources with all variable coordinates. So we had to set up a internal centralized data working strategy. To do this, we chose the SQL import capability of Arches because it allows you to make a relational database of your resource model. So it comes with a set of PLPG SQL functions. You pass your resource model ID to it, and it will create just a relational database with one-to-many relationships depending on how your resource model is configured. And over here on the very left-hand side, you see the Arches interface for resource model, and then this is the Postgres interface where you can see all the branches as views in the database. So having that similar structure to this relational schema, we set up a centralized Postgres database with the front end of a QGIS form that is getting used by our in-house working team to add data into Arches. So it has all the drop downs and different branches, as you can see on top. Once the data is populated into this centralized instance, it gets pushed into Arches through an automated pipeline. Again, it's along like there's an SQL script which includes the SQL commands to import data into each branch. And you have to convert the data into JSON binary objects because Arches now supports internationalization. So you have to say this string is for English, this string is for Urdu. So you have to structure it in a particular way. Once the data is imported into Arches, it looks something like this. So this is some data set from the Madan part of KPK province in Pakistan. But you get, again, the listing, and you can interact with the dots on map by clicking on it and going on to the reports and so on and so forth. One of the really interesting case studies that we came across in the very beginning of the projects when we were working with the historical maps was that when we started to look in these collections, we realized that these historical maps from Survey of India were largely existing as text catalog records in the libraries, and there was no geospatial search interface to like see which map existed. So as part of our georeferencing, what we have been, our team has been documenting detailed metadata about these map sheets, including their physical appearance, the related persons who actually contributed to the map, when this was published, when this was surveyed, and all those attributes. And then we made a resource model within Arches and imported all that data to our Arches database instance. This was also really motivating because in our training sessions and meetings with our stakeholders, they found it difficult to know which resources were existing and where. So to highlight the discoverability part of these map resources, we imported all this data into Arches. And so within the reports or attributes of these map sheets, we have embedded hyperlinks for triple IF images, which are like hosted on the library servers using international image interoperability framework. And these are like really rich high resolution images. So what we do is that we embed the hyperlinks for those map sheets in our database, and the user can click on it and it takes them to the library server where they can see the high resolution map of the image of the map. This is still in progress because the libraries have to host these on their servers, but the use case and the structure is there. We will be populating it as we go along. So we basically are pointing to the library servers, and once this is final, the library catalogs would also be possibly pointing back to the Archie database instance, so the user can find and discover the resources easily. As I mentioned earlier, Archie's from its version 7 supports internationalization. This was a collective effort where different projects contributed to the translation of the static strings within Arches. Using the Transifex platform, you can see progress of different languages on the left. And you can also request, the projects can also request more languages to be added to this list, and they can translate. And then these are pulled into Arches. So on the right-hand side, you can see the Arches interface converted into Urdu, which is a right to left language. So, and it's one of the language from our study areas. Right. So Arches initially used to come up with Arches Collector app, which was used to do ground surveys, and it used Arches data store on the backend. But with the recent rapid developments on the main Arches platform, there is a significant work that needs to be done for Arches Collector to be compatible with the latest releases. So while that is in progress, we are using Open Data Kit to do our field surveys. So ODK is again an open source mobile data collection platform. It allows offline data collection capabilities, and it's largely scalable for low resource environments. Like we are using Kobo Toolbox on the server side that gives you free account creation for up to 1 GB and 5,000 monthly submissions. So our stakeholders, sometimes students in university trainings, and they can quickly make an account and start using our form. And it is also multilingual. So it, in the recent versions of ODK, we can now preload the data that we need to ground truth into the app. It can be seen in blue pins. And then you can attach images with the questions to make it more descriptive. And also we are using the same control vocabulary that we have for Arches within the ODK to keep the data standardized. And once this digital data is available, we can clean it up and push it into Arches. So in terms of future roadmaps, it's available on the Arches project website. There is a long-term stable release version 7.6 planned for September this year. And it will come up with a number of new key features. And then there are plans for version 8, version 9. Arches community forum is really active now. So any user who wants to get started with Arches or has any problem deploying it or any particular feature of Arches, we can post on this, and you will get some support from the actual like a development team or any other project person who has faced a similar thing to just get you going. Thank you.